I've got 5 questions on limits for you here. Let's take a look at them. So here are the 5 questions. 1, 2, 3, 4, 5. So now would be a good time to pause the video, grab a paper and pencil, or grab a whiteboard if you've got one, and try finding the answers here. So evaluate the limits to all 5 of these situations. For the first question here, we have our same equation as we were working with already a couple of times in these live lessons, and we were unable to very straightforwardly solve this where we were trying to find the limit as x is equal to 1, because then we'd be dividing by 0. But as long as we're not trying to solve for the limit where x is equal to 1, so in this case x equals 0, there's no problem here. This is super straightforward. We can just substitute x equals 0 in, and we're able to come up with a solution. So because we're going to have 0 minus 1 is negative 1, we're not dividing by 0. So x becomes 0 here, x becomes 0 here. 0 squared minus 1 is negative 1. 0 minus 1 is negative 1. Negative 1 divided by negative 1 is equal to 1. For question 2, we're trying to find the limit as x approaches negative 5. Now, we can't just substitute in negative 5 for x here, because then we'd end up with negative 5 plus 5. That comes up to 0. We've got 0 in the denominator, and that does not compute. So instead, we'll use factoring here. So x squared minus 25, that can be factored into x plus 5 times x minus 5. If you're unfamiliar with factoring, you can Google and find some quick tutorials on doing factoring. There are some simple patterns that we kind of look for here where, this being a power of 5, for example, is an indicator that some factoring might be possible. And once we've done the factoring, so x plus 5 times x minus 5, we can see here that we've got the x plus 5 terms in both the numerator and the denominator. Those cancel out, and then so we're left with just x minus 5 as our formula here. So now we can substitute negative 5 in for x. So we have negative 5 minus 5. That gives us a negative 10 as the final answer here. All right, question 3 here. We've got another situation here where we can factor. In this case, this numerator can be factored into x minus 4 and x plus 2. You can prove to yourself by multiplying all the terms out here that it will come back to this same numerator. And conveniently enough, we have x minus 4 in both the numerator and the denominator, so those cancel out. And then we're left with just x plus 2. Now we can substitute in 4 for the x. 4 plus 2 is equal to 6. For question 4, we're asked to evaluate the limit as x approaches negative infinity for this fraction 25 over x. So this is the same as we had in this plot here, except now instead of approaching positive infinity, so instead of stretching towards infinity on the x-axis, we're stretching towards negative infinity on the x-axis. And you can probably guess pretty confidently just from the visual here that where x approaches negative infinity, y is going to be equal to 0. Similarly, you could go through and do these kinds of calculations like we did here, but approaching a very, very large negative numbers as opposed to approaching very large positive numbers. So the answer for question 4 is 0. And finally, for question 5, here we have our same fraction again, 25 over 6. But now we're evaluating the limit as x approaches 0. And so what's going on here? Well, there's actually 2 different ways that we can approach 0. So we can approach 0 from the right, or we can approach 0 from the left. And so there's actually 2 answers here. And so this was a bit of a trick question, but hopefully it got you thinking. And let's go over the answer now on the whiteboard here. So we have two different answers, and we use a different notation here. So for the right-handed approach, so the limit as x approaches 0 from the right, this is called a right-handed limit, that comes out to infinity. The curve as we approach from the right-handed limit, the curve stretches towards infinity the closer and closer we get to 0. And as we approach 0 from the left-handed limit, the curve slopes infinitely in the down direction, so towards negative infinity. So this is your answer to question number 5.